Okay, hi guys. We are continuing our study of functions, and today we're going to be looking at the modulus function in particular. So let's try to define what we're talking about. What is the modulus function? Well, first of all, the way we write the modulus function is with these two vertical lines here. So let me draw that, like that, two vertical lines. And let's say we want to find the modulus of 7. So what does this modulus do? What do these two vertical lines do? Well, basically, if the value inside the modulus is positive, then the value remains unchanged. But if the value inside the modulus is negative, for example, here we've got mod 3, then the modulus turns it into a positive, right? So the modulus takes a negative value and turns it positive. That's the basic idea. So if I just give you another couple of examples, let's say we had modulus 5, and modulus minus 63. Okay, 5 is positive, so that remains unchanged, but 63 is negative, so that becomes positive 63. Okay, that's the basic idea. Now, we can try to write this in formal language. Let's say we've got mod x. Okay, what is mod x equal to? Well, then there are two possible outcomes, right? The first outcome is if x is positive, right? If it's greater than 0. And if x is positive, then mod x is just going to be equal to x. Okay? In other words, whatever's inside the modulus there, if it's positive, then the result of the modulus is you just get the same value. So, for example, mod 5 is 5. But then you've got the other alternative, right? If x is negative, then the modulus of x is going to equal to minus x. Now just think about that for a second again. Remember what we did with the example, right? We had mod minus 3, right? So here our x is minus 3. So what does the modulus do to that? Well, you can think of it as timesing it by negative 1, right? So you get minus 3, and that results in positive 3, right? So here you can imagine what the minus sign is doing is it's taking a negative value of x and it's making it positive. Okay, so the key idea is what's the modulus function doing? If x is positive, then mod x is the same, it's just x. But if x is negative, then mod x turns it into a positive, and the way it does that, you can imagine, is by timesing by negative 1. Okay. Let's have a look at a couple of questions. We want to solve this particular equation. Okay, mod 2x plus 3 is equal to 7. Mod 2x plus 3 is equal to 7. Now, this has got two potential outcomes, right? And it depends upon what the value of 2x plus 3 is equal to. Okay, because if 2x plus 3 is positive, then the modulus of 2x plus 3 is just going to remain unchanged. In other words, we will have 2x plus 3 is equal to 7. But if 2x plus 3 is negative, right, if that yellow value inside the modulus there, if that's negative, then what's going to happen is the modulus is going to make it positive. And the way we can imagine that is it times the value of 2x plus 3 by negative 1. So we end up with these two different equations, right? 2x plus 3 is equal to 7, and minus 2x plus 3 is equal to 7. And then we can just solve each of those, right? So 2x plus 3 is equal to 7 means that 2x is equal to 4, and so x is equal to 2. That's one solution. And here we've got minus 2x minus 3 is equal to 7. So minus 2x is equal to 10, and so x is equal to negative 5. So we end up there with two solutions to this particular equation. So we've got x is equal to 2, and x is equal to negative 5. Okay. Let's try another one. If we've got mod of x minus 2 is equal to 6 minus 2x. How would we go about solving that? And the first thing I want to highlight is this thing here. Okay? There's a common error that students make. And that is to think that if you've got mod x minus 2, then that's going to be equal to x plus 2. Right? And the reason people think that is because they've got this idea that the modulus makes a negative value positive. But that's the wrong way of looking at it, right? That's not right, because whilst the modulus, it does take a negative value and make it positive, it's not taking a negative sign here and making it positive. Rather, what it's doing is it's looking at the whole thing in here. It takes the value of x minus 2, and if that value of x minus 2 is negative, then it will make it positive. So if I give you an example, let's say that x is equal to 1 here. Right, so remember, this is wrong. If x is equal to 1 here, then we're going to have the modulus of 1 minus 2, right, because x is 1, which is the modulus of negative 1, and the modulus of negative 1 then is positive 1. Okay, so that's what's happening there, right? So it's whether or not the whole value inside the modulus is positive or negative. That's the important thing. So let's get rid of this. Get rid of that. Let's now try to solve our equation. Okay. Now remember, what we're interested in is whether this value inside the modulus is positive or negative. So if x minus 2 is positive, then the modulus isn't going to change the value, right? We're just going to have x minus 2 is equal to 6 minus 2x. And we can solve that. We get 3x is equal to 8. And so x is equal to 8 divided by 3. But then we've got another alternative, right? It could be that x minus 2, that value, is negative. And so if it's negative, what the modulus is going to do is it's going to turn it positive. And the way it's going to do that, you can imagine, is multiplying it by negative 1. So you end up with minus x minus 2 is equal to 6 minus 2x. And we can just expand that. Minus x plus 2 is equal to 6 minus 2x. So we end up with x is equal to 4. So I add 2x to both sides, I subtract 2 from both sides. So we end up here with two solutions. The x is equal to 8/3 and x is equal to 4. Okay, let's do the last one. Okay, so here we've got the modulus of x squared minus 4 is equal to x plus 2. Again, what's the method? We look at this value here inside the inside the modulus, sorry, and we recognize we've got two outcomes, right? We've got the outcome if x squared minus 4 is positive, and we've also got the solution if x squared minus 4 is negative. We've got these two different outcomes, right? If x squared minus 4 is positive, then the modulus doesn't change that value. We get x squared minus 4 is equal to x plus 2. But if it's negative, then what happens is the modulus makes it positive by multiplying the whole thing by negative 1. So we end up with these two equations. And so we can just solve them now. These are two different quadratic equations. We're going to get x squared minus x minus 6 is equal to 0, which will solve to give x minus 3x plus 2 if we factorize. And so therefore x is equal to negative 2 and x is equal to positive 3. On this side, if we expand out, we're going to get minus x squared plus 4 is equal to x plus 2. So we could say 0 is equal to x squared plus x minus 2. Okay, and does that factorize as well? I think it does. X plus 2 times by x minus 1. Okay, and that's therefore going to give us solutions x is equal to negative 2 and x is equal to positive 1. So in this particular case, even though it's more complicated because we have quadratics, actually the core issue is still the same. We've got two potential outcomes depending upon whether or not the value inside the modulus is positive or if it's negative. All right, and if it's positive, then x squared minus 4 remains unchanged. But if the value is negative, then what happens is the x squared minus 4 is multiplied by the negative value there to turn it into a positive. Okay, so we've looked at how to solve equations using the modulus function. We haven't yet looked at what this means graphically, right? It would be helpful to think about it that way. But at the moment, just need you to master how to solve these equations with algebra. Okay, I hope that was helpful, guys. I will see you again next time.